Welcome friends to 35th module of AI. We have already seen the expert system development process, first two steps in this particular the previous module. In this particular module we are going to look at the remaining four of them. So let us start talking about them. The first step here is prototype construction and conceptualization. The conceptualization, remember I just said in the previous module that conceptualization is quite similar to the analysis in conventional system design process. Remember, the prototype conveys to the user what the final system will look like, will kind of a system, okay, which gives you an idea, okay, a kind of a sketch which gives you, for example, if you want to buy a house and you get a sketch on the paper, it's very similar to the prototype here. So the prototype will give you an idea how the final system would look like. And prototype can be very simple. Prototype can be as good as the final system. And I have told you in the previous module, the best approach to design an expert system is to build a very simple prototype and recursively modify it to represent or convert to the final system. That's the best approach. In fact, it is quite possible that when you take the feedback from users, they just discard it. So, no, this is not what we wanted. Even in that case, you get a very strong feedback on what is not wanted. So many a times you need to again sync between expert, knowledge engineer and the user, but then it will give you at least that feedback. So even if the prototype is discarded, there is still something positive. And very important point is that even when you develop a prototype, simplest prototype or very complex prototype, the most important thing that you encourage people to give feedback and give their suggestion, because it's very easy to change the prototype, is extremely hard to change the final product. Okay, so that's the point here. Prototype construction begins with knowledge acquisition. Now in this phase, expert system, whatever expert believes it to be, his rules, processing, got lot of rules of thumb about everything, and all that is understood by knowledge engineer and recorded. So that is one of the very important part of prototype this thing. And expert and knowledge engineer sit together and do a lot of things. These are shown on the slide. First, they guide the developer in learning about what's the system, what exactly is the system, what is going to come in, what's going to be. So for example, the forms which we call in conventional system, they are called forms. So what people are going to input. The reports, what people are going to see as an output. The key concepts involved in this process. What are the classes involved? Patient, doctor, whatever. Relation between those classes. Which class is a superclass, which class is a subclass, and which class is used by others, and so on and so forth. Which class is a friend of other class. If you're coding in C++, there's a concept of friend. Kind of. What are the processes involved? What exactly a doctor is going to do? What exactly a patient is going to do? Who is going to do with the expert system? Who is going to provide what to expert system? Who expects what from expert system, and so on and so forth is done in the prototype construction phase. Okay, how are you going to solve problem? The basic approach is also decided. Whether you will use goal directed reasoning or forward reasoning, or whether you will use inference at this place or not, and so on and so forth. And KE does intensive investigation here and learns everything about the domain. Because expert is expert. KE, however good KE is, he is not that knowledgeable. Suppose I am going to sit with somebody who is an expert of intrusion, he will start talking about everything that's happening in intrusion, and I'll have to learn. And one of the very important outcome is to note down the jargon used in. For example, the person would say a lot of false negatives, a lot of false positives, and those things. I'll have to learn what are false positives, what are false negatives. We'll have to learn them. So every domain has the jargon associated with it. So if you're sitting with an expert, you'll have to learn all that, because the rules are going to come in form of that jargon, and you have to convert that thing into the knowledge base. So that is very critical part of this thing. Okay, if it is feasible to have some machine learning, so you just can take data from reputed sources like doctor's logs, and the blog is written by somebody, and genuine medical books and things like that, and just bring it to the database. So you don't need to look for symptoms of malaria or typhoid and all that. That information is directly copied in, and you don't even require experts' help there, because that is readily available. You just have to convert that thing to digital form. So if that is the case, you will have to look for and get that. Actually, once he gets this thing, he will meet expert and then try to make sure that expert understands whether he has learned that thing. If he has not learned, expert should be able to explain him what's is lacking and why and all that. And you have to continuously meet and learn from expert in this particular case duration For example, a KE would say that what are the decisions that you make? For example, it would say that when you decide, oh, okay, what are the decisions you make? Do you decide whether this packet requires inspection? When this particular process is to be terminated, when this particular user is to be blocked? Okay, such things, when do you do? How do you do? How do you decide that this user is to be blocked? How do you decide that this process is malicious? How do you decide that this packet requires deep inspection? So you ask them and you learn. Second question, that what are the impacts of these decisions? How many times when you say that if I take a packet for deep inspection and I am right that this packet is really malicious and this deep inspection reveals it, when I suggest a patient to get X-ray, how many times I'm right in saying so, because at that point of time the facts are evident. So when I'm suggesting something, probing something as an expert, why should I be doing it? When I'm doing it, in which situation I ask the user or the patient to do that, and how many times I am successful in my assumption. So those things are the first two things that usually the KA would like to have. What are the essential ingredients? So if you want to have an X-ray, what are the ingredients? The resources, for example, X-ray machine. A deep inspection, what you need a powerful server and with this kind of knowledge extraction process which can tell you exactly what this packet is doing. Particular outcomes, particular situation, whether the system is under danger or not, whether there is under the threat of some attack or not, whatever. Okay, so that is a condition. And there are side of events which influence this decision. For example, the network is really slow, and that prompts me to think that there has to be something malicious happening. The users are denying, the users are denied of their services. They try to access the server, but the server is not responding. There is something wrong. These are indications, these are symptoms of something which is wrong. Same way in other domains, so there are some symptoms which tells you that there is something wrong, and you do that further probing. How experts decide? And what are the past record indicators? I said in last 10 years, how many times you ask for it and how many times you are successful, how many times you are wrong. And the very important, if the expert feels so and the knowledge engineer feels so, if both of them are in sync or they are not, if they are not, why they are not, then you will have to decide. Once that basic questions are answered, here the conceptualization process actually starts. So you decide about knowledge representation system. You say that I'm going to use NMR, or I'm going to add fuzzy component in it, or I'll use certainty factors here. Whatever you do, or say that I'll design classes for it, I design this different types of links and so on and so forth. Whatever decisions that I make, I'll have to have that KE and expert sit together and they decide that this is the structure that they need. That is the beginning part of the conceptualization. And then normal user is also invoked. So when you design this forms and reports, let the normal user read and understand what it is. If they cannot understand, you probably will need to modify, because the interface basically is to be used by the user and not the expert or knowledge engineer. So that it's very important that you also involve user into this process. And if you remember the thing that we have discussed, the interface of an expert system also quite different than conventional systems. You require multiple interfaces. So this expert system, while you are designing knowledge representation process, you are not going to store the knowledge in different forms. Please understand, that will add a lot of chaotic things. In database design, probably if you have gone through a database paper, you know that there is a problem called knowledge redundancy. When knowledge is redundant, we have a problem, because knowledge is updated in one place, the other place is not, and you have a problem. The whole chaotic situation derives out of this problem. So a very important thing is to have no redundancy in the knowledge. So here you don't need to store different knowledge for patient and doctor and all that. There is a single knowledge which is to be converted into all this. So you need to look at the design which can provide all this. Ideally, it should mimic experts consultation model. The program should interact with patient as if the program itself is a doctor. It should follow exactly how a doctor should consult, the patient should consult a conventional doctor. The same way, if he can, or little better, acceptable. If KE might look at different alternatives and decide the best one, and it is quite possible that KE might probably have not understood what expert has said, but once he put it on paper and in the form as well as the report, expert will go through it and realize that this is the mistake, and they may modify it there and then. And that's the reason why KE should put everything that he knows into this thing, the conceptualization. So conceptualization and putting it into a proper form. which experts can also view, and once the expert views it, he will be able to validate that. To validate, the prototype comes next, and validation not only is done by the designing expert, and that's a very, very important thing. The critic, the person who is going to evaluate, is also an expert, but then is not the same expert. He is going to validate this model. Prototype is first thing. The prototype is analyzed on technical grounds. So technically it is sound enough. Okay, there are a lot of things which happen. I am not going to discuss that thing right now, but technical functionality, testing, quality assurance is also a very, very important critical part of every system. Not only leave alone expert system, every system requires that. The outcome of this whole conceptualization process is that now you can write an exact problem statement, exactly what you are going to do and how, in a detailed form. Okay, that you are going to have this knowledge structure where this rule is fired, you will get this, and so on and so forth. And knowledge engineer and expert also learns a lot out of it. Knowledge engineer learn the basic idea about the domain, also learn how expert processes the knowledge, how he stores that knowledge, what is good and bad about this system, what to concern about, where to focus more, and so on and so forth. He learns. Not only that, the expert also learns something out of it. Expert learn about his own role, he learns about conveying his idea. Now that is again a very, very critical factor. Experts usually over a period of time have forgotten how they have come to a typical decision, and they are following it for years. So the reasoning that they had is buried inside their that thing. So they'll have to dig that thing out and present that thing in form of logic, which the KE will understand and the developer will code. So they'll also test their knowledge, and this is a very, very useful, important learning experience. For example, when I worked with one of my students on intrusion detection system, both of us learn a lot of things out of it. So we look back at our own that thing, and we're very happy to learn that our logic is still there. We dig that thing out and put that thing into the code, and that worked. So that kind of a thing will happen with expert in this particular phase. Okay, and you will have to also identify sources, like what are the sources of knowledge. You don't require expert for it. Okay, you can take that data from the reference material. For example, TCP/IP knowledge is needed for intrusion detection, but the whole thing is available in form of RFCs. You just get that RFC and get that information. Next important thing is to verbalize this knowledge. You don't have that knowledge stored in expert's mind or KE's mind. That is to be verbalized, and that this is the other part. An expert actually is verbalizing his knowledge in this process, and when he does that, he himself learns about his own knowledge. Okay, and many a times it happens that both of them take various case studies and see how expert solves that case. Okay, many a times expert will not be able to tell the KE that I'm solving this problem this way, but when KE observes the expert, he'll learn a lot about that. So that's a very, very critical part of this. One more thing is that once this is done, they look at this and understand that the solution should not go in wrong direction. For example, when I'm here to detect intrusion, I should not waste my time finding out differentiating between different attacks, because number of attacks and types of them are almost infinite. If I go on doing it, I'll not be able to solve my problem in my lifetime. So point is, I should not be diverted in wrong direction, but that will be tested in this case. Specific decisions like whether I'll be using a rule-based expert system or whether I'm going to use fuzzy system or whatever will be decided here. Once this is done, I'm entering into the next phase. The conceptualization is over, and now I'm going to formalize my system. Formalization is a very, very important critical phase, which is basically a design phase. So it's basically the first step in the development process. You here the record and organize the knowledge structure. Now you're writing the classes. Okay, if you're in most cases we do it that way only. Now currently the knowledge is almost always coded in some form of classes, because classes offer a lot of advantages like inheritance and so on. Okay, so I'm not here to discuss object oriented programming. You may take up some other course on object oriented programming to understand what is the usefulness and importance of it. But it's very critical that you use that structure, because it offers one of the biggest advantage of reusability. So you need to group rank and order your knowledge. You need to find out missing points in that knowledge. You will have to remove redundant and unnecessary part from the knowledge. See, all that is done now, because putting it on paper, we are finalizing it, and you will have to have a tentative plan ready now. So okay, once the tentative plan is ready, you can start with actual implementation. So this is a very, very critical part of the system design, the expert system design. You will have to also design implementation steps. say, what will you do? You will design the database first, or knowledge base, or you are going to write the rules, or you are going to collect those rules, and if there are more than one experts, how you are going to sync those rules, and so on and so forth. And other stakeholders are also invited, because you are not going to code. If you are an expert, you are going to provide your rules, the heuristic rules. Knowledge engineer will decide the database structure and the knowledge structure and probably XML structure and all that, but he is also not going to code. There is going to be a database coder who is going to design database for it. There is somebody who is going to code this thing in Java or C++ or Python or something. So you require that coder also. You require a tester who is going to test this system, who is going to write test cases and going to run once the system is developed. So, and almost all real world cases, there is a guy who is going to document all this. Those going to run around every corner, understanding what everybody is doing and putting it on paper in a way that later on, if something is to be done, probably this document can refer to as a guide for what is where and how you are going to solve. So, a person also involved from that angle. There is a guy who is administering everything, an administrator, because only administrator will be able to give rights to these developers and testers and all that. So, that person is also required. So, everybody is roped in now, and we have a bigger team in this particular phase. So far only 3 guys were involved: the user, knowledge engineer, and expert. Now every other person now is roped in. The team gets bigger, and everybody is told about the system, everybody gets the idea about the system and will be very clear about their own role in the system. Okay, so that part is done here. So once that part is done, why we are doing that thing? Because we are going to give very clear visibility to every stakeholder. So everybody understand about that system, their own role, and what they expect from others, what other expects from them in a very clear terms. So that is very critical here. So that is one of the important parts of the formalization. Not only that, formalization also talks about checkpoints and deadlines, and will give you a timeline. Then in 2 months time this part is to be done, next 2 months this is to be done, and so on and so forth. That is called planning. Okay, so planning also is part of formalization. And also, like if you have taken some OR course, you probably know what I am talking about. There are some charts which can tell you whether an activity is to follow some other activity, or an activity can happen in parallel with some activity, and so on and so forth, depending on their prerequisites, their requirement, and all that. It's quite similar to that plan space planning which we talked about long back. So this PERT and CPM will tell you such type of charts will tell you exactly what if one task is delayed. Okay, what if a task is delayed, whether the next task will be delayed. If it is a prerequisite, this task is a prerequisite, will have to be delayed. If it is not, if it can run in parallel, you can start. So that is also something that we are going to discuss here. We are going to define. So these are the tasks, and these are the tasks which, and this is the order for this task. These tasks can happen in parallel, and so on and so forth. Obviously, we are going to solve the problem, so we will have to decide the solution as well in the detail. Okay, so you describe the problem in complete detail as much as you can. Remember, you are not going to do this thing to the level that you conventionally do. In conventional, that thing you almost write pseudocode. So the programmer has to just map this thing into that programming syntax. Here we don't do that. Okay, though we say that we are going in utmost detail, means every component of the problem is clearly defined and told that this is to be solved. Okay, functional description of each module, that this module is going to do that. Okay, objectives and the problems. Okay, objectives and the challenges of every module that you are going to work on. Are there any restrictions? For example, for a given module, the response time must be less than 1 second. That's a restriction. Expectation of a normal user, and a normal user expects you to sympathize if he is having a serious disease or something like that. What are the expectations? Sometimes the expectation is that user expects you to explain its reasoning, which is not there in the conventional system. For example, if I get a payslip, I hardly ever go, in fact I never have, and I have not seen others go and ask the clerk why I have got this much of salary. But if I get a response from a medical system that you have got a blood cancer, I would ask why you are telling me so? I don't feel like that. Or you should take this medicine. I would say why do you want me to take this medicine? Then you should be able to explain me. That's the point here. The explanation is very critical here. Okay, and you will have to have various plans for, but design, as I said, is not as detailed as the conventional one. Is usually kind of let it evolve kind of a situation here. It doesn't force it prematurely. That's the issue, because the problem is less structured, and almost every stakeholder beginning of the project is unaware of what they are actually going to do, and that's the fact. After a while they realize, oh, we are doing this. That is quite possible in case of expert system. So we do late binding, we will not fix things unless and until it is a must. And detailed documentation is also very critical here, because things are decided, things are processed, and not only that, they also require to change more frequently than conventional systems. So that's the reason why documentation is very critical. Designing problem logic, conventional diagrams are used in many cases and they are absolutely fine. Knowledge representation scheme also is to be provided in big detail and provide clear cut idea about how the knowledge is represented and how it is inferred and so on and so forth. If there is a model behind this decision process, that model is to be explicitly specified that this is the decision making process, if, else and all that, if so. Remember we discussed about dictionary approach somewhere back, and machine learning that we are going to look at next contains something similar. Information characteristics, what is also very important, because you are going to design your class based on that. Okay. Uncertainties, whether there are uncertain data, uncertain rules, so they are going to be mapped into correct knowledge representation scheme. Okay, so those things are to be done. You will have to decide program logic for this. Now we will have to plan one after the other. The first one is project planning. Okay, you'll have to have resource requirement analysis, budget analysis, descriptions of milestones and all that happens during this project planning. Okay, the diagrams are drawn and experts use it. Utilization, now this is one very important difference. Expert utilization is given the highest priority. So the project planning is done in a way that whenever the expert is available, you should execute things where you need him. Okay, so a project is designed, planned that way, unlike the conventional system. So this is a major difference here. Test planning, we know the experts are invited and experts are given a job of writing test cases and test the system elaborately. Now again, a critical difference is that unlike the earlier case, it is not yes no thing. If whether I get my salary right or I don't get it right, there is nothing in between. So here it is different. When the system says malaria, in out of 100 cases, if it diagnose malaria 70% of time, it is very good, because when Mycin did something similar, it got 72% accuracy. People say it is the worst thing, but then they did the same thing with experts and they have found to be between 62 to 65, and they realize that even experts make mistake. So testing is to be done from that angle, and that's why it is different than conventional system. And you should also make sure that what will happen if the decision is wrong. Okay, so you should try to mitigate the consequences if the decision is wrong, and how you do that is also to be part of this thing. Product release is also planned. Why? Because again, this you probably have seen a lot of beta releases yourself. Usually there is an alpha release as well, which is circulated in the company only, and people who are using that product in the company will come back and give their feedback. The beta release is given to the customers, the usual customers, and their feedback is taken, and then you release the final product. But in case of this thing, expert system, you probably have more than one beta releases and so on and so forth, because the domain is more unstructured, and probably the system itself is less structured as well. You check for abnormal cases as well, which is not possible in conventional cases. A lot of abnormal cases might be there, because every other system says that it is malaria but the patient has typhoid. That is possible. Support planning comes next. Now support planning requires you to, like when you roll out the expert system, people take time to get used to it, and they face more problems than conventional systems, because these are different types of systems. What you need is support planning, how you do it. Okay, unless you do this thing right, there's a huge possibility that your expert system is going to fail, because if you don't do this, will not have that level of acceptance as user. So this is also a very critical phase. There are a lot of things here that you need to know: how users can communicate problems to the company, who will be responsible for handling those customers' problem, what type of support staff is needed, how system configuration and implementations are handled, how domain experts are used to handle these problems, and so on and so forth. This is a more critical part than it looks at the first shot. So this is very important. Implementation planning comes next. Now implementation planning is basically how you are going to implement this, deciding about the classes and all that. And after implementation planning, obviously the last phase, implementation, starts. For a large expert system is pretty critical. So what you are supposed to do is to divide the expert's knowledge into knowledge chunks or knowledge segments, and knowledge segments is made up of many rules. So there are few thumbs up rule. These knowledge segments should be as small as possible, and they should contain knowledge chunks in a way that conventional law of cohesion and coupling is maintained. So we would like to increase cohesion in the segment and reduce coupling between segments. So that is again a very critical point here in the implementation. After that, you start the development process. Okay, the basic framework, inference engine is decided, user interface is decided, and core knowledge base is constructed, new class, rules, everything now is written, implemented, the test data is inserted and start. Any ancillary part that is required is also added to this, okay, and testing and all that is required. An interesting thing here is, like, the first case is inserted, you test the system. Second case is inserted, you test the system for both cases. Third case is inserted, you test the system for third case and all that. Why? Because remember, we have done something in the goal state planning. We have learned that it is quite possible when you add a new task, you're testing for malaria, you may do something which fails the test of typhoid that you do earlier. So it is quite possible that it is tested this way, and that's critical part in the processing. Obviously, the knowledge based processing comes next. You have to decide how knowledge base is going to process the queries of the users. Testing and evaluation comes next. Testing is again, as I said, a very critical part. The experts are involved in this process. So there may be more than, and this again, we are talking about real systems where there are more than one correct responses. It is quite possible. We are dealing with real systems. It is quite possible that one expert says that malaria, the other says typhoid, and the patient actually has both of them. So that is possible. So that doesn't happen in conventional systems, but it does here. So testing is comparatively more difficult. Evaluation of a system is also done here. Maintenance and extension is also part of this part. But the maintenance is not only maintaining the expert system, but continuously improving it for quite some time. So that also requires a lot of additional exercises. And remember, knowledge update is a critical problem. And we have seen how critical that is in earlier modules. So I'm not going to talk in detail about it. But the idea is to have users input and other experts input and get the system better over the period of time. Provide corrections to the knowledge base. And sometimes the primary expert himself, okay, he might also say that this system is to be redesigned, because now he has learned everything and he can suggest that this is the mistake that I made and I'd like to improve on it. Please accept such things, okay, because expert systems are almost always designed this way. So in the next rollout, they make all these changes, and next version they change. Whether the other experts are invited for additional components that you would like to add or not, that again you might probably think. You already have intrusion detection system. Now you are also going to add a policy enforcer. Do you need an additional expert for it? You may invite, and you may run both things together because the customer wants it. So you may need to do that. This state actually converts the formalized content into the code. That is the minimum thing that you do in this phase. And its very crucial part is KE and developer communication. Now expert obviously has given his knowledge. Now that knowledge is to be completely modeled into a computer program. That KE and developer is the communication is pretty critical here. And it constructs actually a lot of other important outcome. You have a long-term maintenance plan, you decide that thing and write that thing down. Interfaces are to be decided, modification of those interfaces and all that can be thought of, okay. Extensive plan to help user out from any problems encountered working with the expert system also is to be charted out. And obviously, you doing all this, you also have to have some kind of performance assessment system, because there is a likelihood of failure. You'll have to continuously check whether the performance of the system is improving or not, and what are the concerns about the when the system fails to detect intrusion, or when the system fails to detect a disease, when the system incorrectly classifies a disease which is not, and so on and so forth. You will have to find out those areas and make sure that they are addressed, and the performance is improved to the extent that is acceptable at expert level. So that also is very important. And technical nuances that you probably can use, like taking direct data from IMD into medical system, or storing data directly in the cloud so all users can have it, and so on and so forth, can be quite handy, quite useful. You will have to manage uncertainties. So whether you are doing it well, if you are not doing it well, whether your plan contains managing uncertainties these are crucial ingredients for making the system run for a longer period. Rule execution also is to be tested, like whether rules are properly executed, whether you need to reschedule the order of the rule, whether you need to fine tune those rules, that also is to be properly done. Control strategy, which decides which rule to apply next, might require fine tuning in long run. You may have to also think that. With that, we come to an end of this module. We have discussed last 4 steps of expert system design process. In fact, I have just given you an idea about this. You probably read this or look at the PowerPoint slide to read more about and understand, because I have given a lot of examples of intrusion detection system and other systems in my discussion, which I couldn't do it here because of the time constraint. So you may look at them. And let me recap what we have done in this particular module. In this particular module, we looked at conceptualization, prototype construction, then we have looked at formalization, then we have looked at the implementation, and then we have looked at the testing part of the expert system design. With that, we will conclude. Thank you.